Welcome my dear friends, let's know how to develop a robot, a full mobile robot. So you can see there is a tricycle model, this is a caster wheel, this is a motorized wheel, this is also motorized wheel. So you can look at the inside the robot, you can see the wires are came out, like we bought these wires out because we have two motors here, two wires from here, two wires from here, and you can see this is a tricycle model here also. So let me draw the things. Here I have a caster wheel, here I have a motorized wheel, here also I have a motorized wheel. So now we can compare. And I have a DC motor here. So typically I also have a DC motor here and also have a shaft. Like the motors are here internally, here also motors are there. So this is a tricycle model. And coming down to this particular robot, you can see there is a length and the width and the height of the robot is there. How do we decide everything? So let's understand the basic parts required to decide the size of the robot is your 1 is, 2 is here and 3 is here. This is your motor, this is your wheel, it's like your motorized wheel. Then this is another wheel, caster. So this is your caster wheel. This is your motorized wheel. This is your DC motor. Coming down to the motor. So we will do one thing. We need to find out the length of the body, length of motor body, then what we need else? Then we need to find the diameter of your shaft. Then coming down to your wheel, we need to find the diameter, meter and width. So these are the four things we need to understand. Then coming down to your caster wheel, we need to understand the height. This is your motor. You can take a vernier scale or I am taking a general scale. To get a more precise data, you can use a vernier scale and the measurement is approximately 4.5 centimeter you can see. Or else you can take a vernier scale and you can have a better measurement. So, and the diameter is exactly 0.6 mm. So you can take a vernier scale always to measure the diameter as well as the diameter of the motor body or else the length of the motor. The answer we get here, the motor body length is like 4.5 centimeter and the diameter of the motor shaft is 0.6 centimeter. Coming to the wheel diameter, you can take the wheel, again you can use a vernier scale and you can do the measurement here. It's like again 7 centimeter and the width of the wheel is exactly 2 centimeter. So I can say this is 7 centimeter and this is 2 centimeter and the height of the caster wheel is always again dependent. This is a caster wheel. The height of the caster wheel is always this is 1 point. You can take the caster wheel and you can start measuring it with a vernier scale, but I am just using a general scale. You can use a vernier scale. This is 1.6 centimeter. So it's like 1.6 centimeter. So please have this data because it's a pretty simple mathematics we need to do now. With this data, we'll develop a robot now, the mechanical robot. Let's assume this is your body and I'm not specifying the motor, like I'm not specifying anything like the width or height or length of the body. Let's find out the one by one. So once we are developing a robot, we need to put a motor here, another motor here. and the shaft will come out here. The shaft will come out here. This is the basic design, and everybody know that this length of the motor is your 4.5. Each motor 4.5 centimeter. So 2 meter can give you 9 centimeter, and we just need to give a gap between these two motor is exactly 1 centimeter for avoiding any kind of short circuit. So altogether we can say this is 4.5, 9 plus 1. So I can conclude the size of the body should be 10 centimeter at a minimum. This is the width of your robot body. Right now you can connect your wheels here, and this is your motorized wheels. The moment you connect your wheels, then you will find certain distance between the body and the wheels, and you need to take these 3 wheels and form a equilateral triangle. So this is the point, this is the point, first 2 points. So the distance between this point and the robot body is exactly 1.5 centimeter. So right now we can conclude if this is 1.5 centimeter, so the length between these two part of your robot is 1.5 plus 1.5, so it is like 1.5 plus 10 plus 1.5, 13 centimeter, right. So once we got this particular output, like the distance between these two is 13 centimeter, so right now you need to find the where you are going to put your third wheel. So the third wheel must put in such a way so that these 3 will form an equilateral triangle. So you need to form a virtual equilateral triangle, so where your side is 13 centimeter, A is equal to 13 centimeter. This is the equilateral triangle, and you need to find the height. So this is your height, so that you can take the height from here, and this height would be the answer. So it can because these two are the virtual, this is virtual, this is the physical space. So right now you need to take the height. So what is the height of an equilateral triangle? So the question is now, height of an is equal to, answer is root 3 by 2a. So here your answer can lead to this, root 3 by 2. Your A is equal to 13 centimeters. So it's like A is equal to 13 centimeters. So it's like 13. So you can say 6.5 root 3. So right now you will get approximately the answer will be 11 centimeter.